Well, good evening, everybody, and welcome to the Senate Room this evening for the inaugural lecture of Professor David Chesters. Professor David Chesters, as you'll hear in the introduction just now, joined us on stepping down from the University of Liverpool and came to the department and has now been called on to lead the department. And as you all know, he brings a great depth of experience, breadth of experience to the task, and we are delighted that he is part of the geography and environmental science team here at the university. Geography was once one of the largest departments at this university, and like sociology and the fashions of the time and computer science in the 90s, these are some of the subjects that shrunk as trends and fashions change. However, we were determined, even though the tide was against certain disciplines, from time to time against certain disciplines, that we will maintain core subjects irrespective of what the market does, because the university as a university will be poorer if we let the market determine our natures. However, the tide seems to be turning, because I looked at the latest applications from Mrs. Harvey, who I saw in the congregation. I looked at the figures, and the numbers for geography and environmental science are growing again. Oh, I hope that's going to be an omen of great things for the future. The inauguration of new professors strengthens the academic resolve of the university. And we have also on these occasions a chance as the academic community to listen to what heads of departments and their teams wish and hope for the departments in the foreseeable future. It's my pleasure to welcome some people in particular. I should begin with Mrs. Jennifer Chester, the wife of our speaker tonight, who I hope to meet in a short while. We also have several colleagues from the University of Liverpool here. A special welcome to all of you. I'm going to name you if you don't mind. I may miss out one or two. Let's hope not. Charlotte Billingham, Dr. John Boyle, Dr. Neil MacDonald, Professor Andrew Morse, Dr. Mark Riley, Ms. Claire Rimmer, Dr. Heather Sangster, and Ms. Andrea Wall. We also have a colleague from the University of Bedfordshire, Professor Angus Duncan, with us. Very welcome, Professor. And Professor John Shembry, all the way to join us tonight, specifically for this occasion, from Malta, the University of Malta. I should give you a foretaste of things to come. Professor Shembry will be receiving an honorary doctorate from this university at its July graduation, so welcome, Professor Shembry. I should also welcome some other guests, Dr. John Houston, who's in the Sand Dune Network at Hope, Ms. Frances Esketh, the Director of Environment Partnership, Councillor Malcolm Kennedy, the Cabinet Member for Regeneration, Transport and Climate Change, and of course one of our holders of the honorary degree and former governor of the university, Bishop Vincent Malone. So welcome everybody. And now I'm going to invite the Pro-Vice Chancellor, Professor Kenneth Newport, to introduce our speaker. Professor Newport.
Well, good evening, everybody, and let me first of all add my welcome to that of the Vice Chancellor to this, the first of our inaugural lectures for 2016. It's always a great privilege to be asked to say a few words by way of introduction on these occasions, and as usual, there is so much that I could say that I barely know where to make a start. But my time is limited, so I'll begin with Professor David Chester's graduation with a first-class degree and the University Prize for his subject from the University of Durham. From there, Professor Chester went to the University of Aberdeen to complete a PhD. His research was funded via the Natural Environment Research Council Studentship Award Scheme. And in 1996, in what looks like a slight change of track, he was awarded a postgraduate diploma in applied theology from the University of Liverpool. And that was, of course, a sign of things to come, as a few years later, David was ordained a priest in the Church of England. Professor Chester is a chartered geologist, in which capacity he was employed by the university for a very long time, over 35 years. He became a fellow of the Geological Society in 1988 and a chartered geologist in 1992. He is a visiting professor in the Faculty of Science and Computing at the University of Luton. Professor Chester first joined Liverpool Hope in 2013, where he now holds the chair in environmental sciences. And we are, I have to say, delighted to have him with us. As those who know him will doubtless confirm, Professor Chester is a very kindly and gentlemanly colleague, as well as a top-rate academic, and we are very fortunate to have him as part of our community. For many years, Professor Chester has carried out research on disasters, particularly those produced by earthquakes and volcanic eruptions, and since the mid-1990s, his research has focused on such important topics as religious responses to extreme events of nature, the human impact of major historic disasters, hazard reduction, especially those in Portugal, Italy, and more recently Malta. Professor David Chester has more lately combined his pastoral and his academic interests through exploring the ways in which faith communities in particular respond to natural disasters. Professor Chester is either the single or the joint author of 7 books, at least that's how many I was able to count on the CV. And in addition to that, numerous book chapters and refereed papers, and altogether, I did try to count them, altogether I counted around 90. I wouldn't say it's absolutely spot on, but certainly around 90 of these. They range from the most recent paper, a paper on the distribution of soils on Mount Etna, published very recently, to a paper back in 1975 on possible interglacial pollen flora in Scotland. And as I read the CV, I was particularly struck by the consistency of Professor Chester's output. Between 1975 and 2016, barely a year seems to have passed. In fact, I'm not sure one did pass at all without something appearing. And of course, given that we are talking about more or less 100 outputs, including the books, in many of those individual years, there are several publications. Professor Chester is a committed teacher who has taught across all levels and across a range of subjects and areas within his broad subject expertise. Such includes natural hazards, pure and applied volcanology and seismology, environmental history, soil science, geomorphology, history and philosophy of geology. He supervised 7 PhDs and has been an examiner of many, many more. Well, with all this, it's a little bit of a surprise to find that David also has time to serve as a non-stipendiary minister at St. Bridget's in West Kirby. Prior to taking on this responsibility, he served at St. Hildeburg's in Hoylake. He also enjoys reading, 20th century history and biography, and has more than a passing interest in railways and aviation, and still finds a limited amount of time to carry out DIY. A busy man, it seems. But thankfully, Professor Chester has managed to fit us in to this busy schedule. And this evening, it's a very great pleasure indeed to invite him to deliver his inaugural lecture on the subject, What Happened Then Matters Now, Reconstructing the Impacts of Historic Volcanic Eruptions and Earthquakes. Professor Chester.
Thank you very much, Professor Peely, and thank you, Kenneth, for those very kind words. I hardly recognise the person who's being so described. Just a few preliminary remarks before I actually begin this presentation. Vice-Chancellor, colleagues and guests, I think there are many people I need to thank in a long career. In a very real sense, every academic harvests other people's flowers. And as many here will be aware, it's a difficult matter to be a member of an academic's family because scholarly activity especially research, can become somewhat obsessive. I therefore start by thanking my wife and daughter, Jen and Olivia, for their forbearance and support over many, many years. Also, nobody achieves any success in the academic world without inspiring teachers. At Altrincham Grammar School, which I had the privilege to attend, I pay particular tribute to two late mentors, Norman Dorr and Roy Coleman. At Durham, where I read for my first degree, that my tutor, Bill Fisher, was a powerful influence upon many students, including me, while my research supervisors, David Stoughton and Chalmers Clapperton at Aberdeen, were ideal mentors, largely because they let me get on with my work on my own and learn from my mistakes. And they may regret that I didn't become a glacial geomorphologist, but there again, perhaps they don't. In my academic career, I've been very fortunate to have had a string of excellent research collaborators, all of whom are now friends. I include in particular Angus Duncan, who I actually met on my very first day at university in Durham more than 45 years ago, the late John Guest, Peter James, Chris Kilburn, Bill Maguire, David Alexander, Chris Dibben, John Shembry, Ritien Gauche, Carmen Solana, Martin Degg, Rui Coutinho, Nicolau Wallenstein, João Gaspar, Gabriela Quiros, Kevin Edwards, and Stefano Branca. In the geography department at the University of Liverpool, where I served for over 30 years, there are far too many colleagues and students to name, but I'd like to thank in particular the late Dick Lawton, my first head of department, and a model leader in all respects, Adrian Harvey, Jeff Thomas, Phil Lister, John Dickinson, Paul Laxton, David Siddle, Pete Crimes, Andy Plater, John Boyle, Peter Lloyd, Neil MacDonald, Heather Sangster, Mark Riley, Bob Woods, Andy Morse, Katie Willis, Sandra Mather, Alan Hodgkinson, and Bob Pullen. Finally, and by no means least, my colleagues at home with whom it's a great pleasure to work, Janet Speake, Victoria Kennedy, Mary Rice, Paul Rooney, Kevin Crawford, Peter Sisker, Steve Fowler, and Bernard Quinn. I've been to many inaugurals, and speakers tend to adopt one of two models. Some people review their whole career, and others provide an academic lecture. I've chosen the latter course and effectively had a choice of discussing the Italian or Azorian volcanoes, the importance of theology in shaping responses to disaster, or an in-depth presentation using a seminar format. What I've chosen is to do a review of a field I've worked on now for more than a decade, and which involves the use of a combination of archival sources and fieldwork to assess the impacts of historical earthquakes and eruptions. I hope it will appeal to many wide interest of people represented by this audience this evening. All the papers I will mention have been joint efforts, mostly with Angus Duncan, one with my daughter Olivia, and several with colleagues, both in Italy and Portugal. And if anyone is actually interested, then I can actually provide any off-prints of the papers if people just write in and ask. Right. So what I want to do in this presentation, therefore, is to draw lessons from a study of various historic eruptions and earthquakes which I've studied over the last 10 years or so. And I want to concentrate in particular on the 18th century earthquakes in the Algarve in Portugal, particularly the 1755 so-called Lisbon earthquake, which was even more devastating in the Algarve than it was in Lisbon, the 1944 eruption of Vesuvius in Italy, the 1957-58 eruption of Capellina's volcano, and the 1958 earthquake in Fayal Island in the Azores, and historic eruptions of Mount Etna in Sicily. Our team, and it's been a very flexible team which has had different members in it over the last 10 years, has worked on other events, including the important 1906 eruption of Vesuvius, and we're currently researching the impact of earthquakes and eruptions in the Azores since settlement in the 15th century. Why is it important? Well, it's important for several reasons, I think, because it's becoming increasingly apparent that understanding cultural issues that are raised when volcanoes erupt or earthquakes occur is actually very important. Indeed, one of the principal findings of the United Nations International Decade for Natural Disaster Reduction, which ran from 1919 to 2000, which is further developed by the International Strategy for Disaster Reduction, which is current at the present time, was that a greater focus on human vulnerability and resilience and the unique character of specific places and cultures was very important in understanding responses and indeed in understanding how to plan for future events and to innovate policies of hazard reduction. And the influence of cultural features of a society has been traditionally underreported in studies of the responses of societies to natural disasters, not only in the economically less, but also in the economically more developed countries. So it's actually been a universal lack of study. Cultural vulnerability and resilience may be important considerations in assessing how societies cope with future emergencies, and also their receptiveness or otherwise to outside intervention. Examples of the importance of cultural responses are captured in many contemporary accounts, which range from official reports, archival data, academic papers to newspapers of records, in some cases survivors' reports, and others folklore. And one of the great advantages of living in this place and this time is for the very first time we have many of these sources available electronically, and these electronic sources can in fact be interrogated. And we do, through translation software, have the ability to range over quite a number of language sources, and far more than we'd be able to do if we simply had to learn these languages, no matter how adept we were at foreign languages, which I must say is not one of my strongest suits at all, so I'll pass discreetly over that one. And for the physical geographer and earth scientist, the availability of large quantities of archival data has really transformed the data that's available for research. We've traditionally been very much dirty boots field men and women, and to that, and there's nothing wrong with that, I mean, all of us have enjoyed that kind of work, and I still do, but we've actually got a whole range of new material available to be researched and to combine with these other traditional archives which we've all worked on. Historical reconstruction of historic events of an extreme character, I think, are important for two reasons. First, often events, even those that are recent, were not really fully recorded at the time within the academic literature, and so it's impossible, without going back to the original sources, to know exactly what's happened. And also, the way a society responds and the authorities act are very important considerations, as I think we'll see as I go through the examples in future civil defence planning. So first of all, the first of these case studies is some work I was involved in some years ago now on the 18th century earthquakes in the Algarve. And some of this work, my daughter graduated from Liverpool University and had a time between graduation and starting a law course, so in a typical academic way I recruited her to do some work for me. So we had the pleasure of working together on this work, and if anyone's interested in this paper, I can supply it quite easily. And the two events which really impacted the Algarve in southern Portugal were the 1722 so-called Severe earthquake, which had a magnitude of 6.5 to 7.8 estimated, because of course you can only estimate it because it wasn't instrumented, and it severely affected the coastal zone of the central Algarve, and also the very famous 1755 so-called Lisbon earthquake, a magnitude certainly 8.5, possibly more, caused the death of 12,000 people in Portugal, not the 60,000 that's often quoted, and 1,000 of whom lived in the Algarve, which was devastating at the time because it wasn't actually very densely populated at all. These are the isoseismal lines, which are lines of equal damage, building damage, and the intensity scale, these values in Roman numerals, are the intensity. 12 is absolutely devastating, and any values over 6 or 7 are certainly very severe. And you can see what impact it had. There's Tavira, very nice place to go on holiday, an extremely good hotel there. The Posada there is certainly a great hotel to stay in, stayed in it many times. And you'll see that the impact was really very severe. So if you take the intensity lines of 7 and over, then many of the tourist resorts that many of you have been to, Portimao, Lagoa, Albufeira, Fara, Lule, Tavira, were absolutely devastated by that event. And the major sources we have for 18th century events are 2 surveys. There's what's called the Marquis de Pombal survey, which was carried out after the 1755 earthquake, but also had some questions on 1722. And what's called the Parochial Survey, a questionnaire to parish priests in each concelho or a county, and each frexia or village affected by the events. And it's the parochial survey that's particularly important for the Algarve, because much of the survey of the Marquis de Pombal survey for the Algarve is actually missing, so it's lost. But the parochial survey was particularly useful, and using these sources and others, we're able to, this is Pombal and the New Lisbon. I don't want to talk about that because I could bore you very easily with that. That's another topic. But these are the isoseismal lines for the even more severe 1755 earthquake. You'll see that this is a map of the whole of Iberia, absolutely devastating, over 11 intensity, and 12's the largest it can be in terms of damage, total damage. And you'll see that we're not exactly sure where the epicenter was. It was actually much debated, but was certainly off the west coast of Portugal. And you'll see that there's an attenuation or fall off in seismic intensity as you move north and east away from Cape St. Vincent. And again, causing major damage throughout this part of Portugal. What are the principal findings? Well, the principal findings are these, that although the 1755 was the most extreme scenario there could possibly be, and indeed has a recurrence interval, which is difficult to calculate for several reasons, but it's probably about 600 to 1,000 years, is potentially not the most damaging scenario for the Algarve. Estimated deaths up to 3,000 if it occurred again, but the 1722 is for the Algarve a much more dangerous scenario because it was centrally located. The estimated deaths, if it occurred today, would be at least 12,000, and the recurrence interval is actually quite low. For an earthquake of that magnitude in Iberia, about once every 600 years. And remember, the probability is like throwing a 600-sided dice, so it's in fact every year that's the possibility of it occurring. Soil amplification effect is very evident. It's something that we know about in earthquake zones now. So if you have loosely consolidated materials, then the reflection and refraction between the various layers can cause an amplification. And indeed, in some parts of the Algarve, it's thought that there may well be an increase of one integer value in the magnitude figures. And if you move from magnitude 7 to a magnitude 8, then in fact you don't actually increase the energy expenditure by 10 times, but by 32 times. So in fact it's a massive increase. But the traditional rubble stone buildings, which are still there throughout much of Portugal, are very dangerous because buildings kill people, and most of the losses in virtually every earthquake are building losses. And away from the coast, it's still the traditional building type. A strong religious response, but quite interesting, it didn't actually inhibit the people accepting any outside help. It didn't actually dumb people into simply being fatalistic. And many lessons learned at the time about construction standards were very quickly forgotten. So just a few slides of the area. These are traditional buildings. These are really quite safe buildings because they're a simple structure, they're single story, and they're actually quite well maintained. More problematic were some of these buildings which were, this is the Jesuit College, and it was rebuilt exactly how it was before, after the event, which was not ideal. Plenty of openings, complex structure, various frequencies of vibration of the various bits, a very dangerous construction. But Pombal himself tried to impose building standards not only in Lisbon but also in the Algarve, and this is the rebuilding of Faro Old Town, and this is good construction, simple lines, high standard workmanship, little ornamentation. The roof divided up because fire was a major problem, so they divided the roofs up into set sections. And that would be thought to be very good at post-earthquake construction. The one thing they didn't know anything about was foundations. And indeed, this is some more Pombal-inspired construction in Villarreal de San Antonio, right on the Spanish border. The only problem in this town, this really flatters the place in a way, because in the 19th century, the structural integrity of some of these buildings was compromised because they opened up the ground floors to create shops. So in fact, it was actually, some of the shops there are actually quite dangerous. The second example I want to look at, and this is some work I did with Angus about 10 years ago, and this is the 1944 eruption of Vesuvius, southern Italy. We published it in two places, one in Journal of Historical Geography, and then we also did a briefer version of it in History Today. Indeed, my title of my lecture today is a steal from History Today, because that used to be their strapline. What happened then matters now. So, Vesuvius in southern Italy is one of the world's most dangerous volcanoes. It has around 600,000 people living on its flanks, and it's got about 3 million people within range of a future eruption. And March 1944 was the latest, but probably not the last eruption of this volcano. And despite of its relatively recent date, the responses of the population authorities to the eruption have until very recently neither been recorded fully, nor have they been evaluated. And the reason for it is really within the date, because it was at the height of the Second World War. There's Vesuvius in 1944. You'll see there's the city of Naples in the foreground, and there's Vesuvius in the background. It looks pretty well built up then, but if you actually compare it with what it is now, you look at those two slides, the unplanned and rather chaotic development that's taken place in the post-war period has in fact increased hazardousness of place quite significantly. This is a slide I took from the dining room of a hotel called the Hotel Jolly in Naples, and it isn't that jolly. But anyway, those are the two. Those give you some idea of change through time. Here's a slide, like many of my illustrations, very expertly drawn by my friend Sandra Mather, and you'll see these are various the products of various eruptions that have been produced in the 20th, the 19th, the 18th, and before. And you'll see that just the fact you can colour in a map with different colours suggests just how active it's been. Since 1944, it's been in a series of, it's been quiescent, but that doesn't mean it's not dangerous. This man is very important because this is American, Lieutenant Colonel Kincaid, and he was the person within the Control Commission in Naples who had control and responsibility for handling the eruption and its aftermath, and how the Allied authorities were going to respond. And he did an excellent job. And what's more, he left a memoir, which actually is there in the British archives, the American archives, and in Italy. And that memoir was one of the most important documents we had in reconstructing the response. This is a slide showing really what happened at the time of or what the situation was at the time of this eruption. The Battle of Monte Cassino was still in operation. The British 8th Army was there on the Adriatic coast, and the American 5th Army on the Tyrrhenian Sea coast. And it's no wonder that it was very difficult to actually manage this eruption in terms of any kind of response. And the fact they did so was a great tribute to the Control Commission and the officers and men who worked under Colonel Kincaid's command. As I say here, that Italian science and social science were in a parlous state due to the exigencies of war. Civil administration had only been recently re-established, and conditions across southern Italy were grim. There was a severe lack of food, and this was exacerbated by problems of disease, wartime destruction, dislocation, and indeed lawlessness. Yet in spite of all these problems, we argue in this paper that the management of the emergency by the Allied authorities was both impressive at the time and holds, moreover, important lessons how similar eruptions could be managed in the future. There's abundant documentary evidence contained in the official archives in the USA and the UK. We managed to do it in time to get lots of oral testimony from some of the soldiers who had actually been involved in it, from surviving service personnel. We perhaps should have done it 10 years before. We always said it would have been better if we thought about this project 10 years before, because there would have been more people available. We also managed to interrogate meteorological databases to provide an insight into the influence of weather conditions on plume direction and temperature deposition. And we've collected plenty of field data from local authorities, local authority councils affected by the eruption. Here's some of the archive photographs we obtained. There's the part of the eruptive plume from the event. There's an advance of the lava through the village of San Sebastiano in 1944. In fact, there's actually archive film, newsreel film as well that we used. This is the extent of the deposition of the tephra, or volcanic ash, from the eruption, and you'll see it covered a very wide area right across to the Sorrentine Peninsula, through Salerno, 6 centimetres falling on Salerno, and gradually as you move to more proximal locations, those that are near to Vesuvius itself, of course, it gets a lot thicker. What are the principal findings of this work? Well, in spite of the region's reputation for lawlessness, panic and